I would do this question. Just says, here's a polynomial. You divide by this, you'll get that remainder. You divide by this, you get a different remainder. Okay, so how does it work? Well, it's a pretty straight use of the remainder theorem, right? Let's take this first line, and the zero that corresponds to x minus 3 is 3. So you just say p of 3 is going to be 120. Okay, so you come up here and you say, well, what does that mean? You substitute it all in. You're going to get, on the left-hand side, 2 times 27 plus 7 times 9 plus 3a plus b. That's 120. Yes. So I've got 54 plus 63 plus these two guys. So you subtract both of those. Both of those are what? 117. So I'm going to end up with 3 over here. Yes. And that's going to be one of my simultaneous equations. I know I'm going to need 2 because I've got 2 unknowns, right? All right, there's my first equation. Make your second one by taking this equation. So in the same way, p of minus 1 is minus 8. You rehearse the same thing. 2 times minus 1 plus 7 times 1 minus a plus b. That's going to give me minus 8. So far, so good. Minus 2 plus 7 minus a plus b equals minus 8. That's 5. So you take it over, you get minus 13. And there's your second equation. Okay? Now, assuming my numbers are okay, and I'm in a hurry, so I'm not going to bother checking. From here, that's fine. No problems. You guys know how to solve simultaneous equations. Okay? And you probably already have your answer for this. Okay? But these are the important 2 things that you want to get in your working. Okay? Because it shows you understand what the remainder theorem is. Now, you come to this question. Let me just try to word it for you because it's a bit succinct. They say there is a polynomial, and they don't even tell you what it is. Okay? So it's not this kind of scenario. They do tell you that it's got a degree greater than 3, so it could be 4, 5, 6, 7, 8, right? And then they give you similar information to what they had before. If you divide by this, you'll get this remainder. If you divide by this, you'll get this remainder. Okay? Now the question is, what happens when you divide by both of them at the same time? What happens when you divide by x minus 4, x plus 3? Okay? The product of those two divisors, right? What remainder will you get in such a case? All right? Now the first thing you want to notice is that when you divide by something with a degree 1, okay, what you end up with as a remainder has degree 0, right? I should probably put a D there. Okay, which makes sense because when you divide numbers, right? I think the example I gave you is like 300 divided by 7. Okay, the remainder you're going to get is always going to be less than your divisor. Wouldn't make sense to get one equal to or more than what your divisor is. Okay. Now, since polynomials, it's not about numbers, it's about what power is on x. That's how we divide through polynomials, okay? The same principle carries here. Now, if I'm dividing by a divisor with degree 2, I should expect my remainder to have degree 1, okay? So therefore, I'm going to set up my remainder theorem like this. I'm going to say p of x, right? When I divide through by both of these things, if I actually knew what p was, okay, I'd get those and then I'd get a quotient at the end, which would itself be another polynomial. Call it q for quotient, okay? But then, assuming it doesn't divide through, it actually has a remainder. It will have a remainder of degree 1. Now, if it's degree 1, it's some x and some constant. So I'm going to call that, ax plus b. That's the remainder that I'm after, okay? That's kind of a crucial step. It's hard to see because it's like, well, I just sort of made it up, okay? But this is actually what I'm solving for. Now, once you've got that set up, this question, despite starting so differently, proceeds just like this one, right? Because I'll say, look, on the basis of this, the remainder theorem tells me that p of 4 will be 4, okay? So you sub it in. Now, I don't know what p is, but I don't need to, okay? Because of the remainder theorem, when I put 4 in, this part will just vanish, okay? And I'll be left with this, okay? But it's got an x in it, so that's going to be 4x plus b. See that? Is that okay? All right, again, first of my 2 equations. Sorry, yeah, that's right. I subbed it in for x. Okay? You repeat it for this, so that means p of minus 3 will be minus 10. Okay? So therefore, again, it's going to be minus 3a, got it right this time, plus b equals minus 10. Okay? Now, because this just looks a little different, up here, I'm just going to solve it for you and finish it. What are we going to do? How shall I combine them? Looks like I'll subtract. Yeah? 1 minus 2. That's going to give you 7a equals 14. So that gives you a. And if you bring that back up here, that's going to be 8 plus b is 4. So b is minus 4. Okay? Now, that's not the answer. Right? Usually they say, just tell me what a and b are. The question was, what was the remainder? So you've got to bring that in and say, the remainder will be 2x minus 4. Looks different. It's the same question, just in different clothes.